So now we're going to tackle our next data structure, the queue, spelled Q-U-E-U-E, and pronounced, well, just the first letter. So the queue is possibly the easiest data structure to that we will go over in this class. So because it's very conceptually easy to explain. So imagine a line of people. Don't make any changes to that image, and you're done. You've imagined a queue. Because a queue is exactly what it says on the tin. It's a line. So you can visualize it as a line of customers waiting to be served. Another way to view it is, we typically view it as like packages to be processed or tasks to do. So, but conceptually, the way this means is that the next person to be served is the one who has so far waited the longest, right? So new elements, they get put onto the end of the line and then they have to wait. And once they're at the front, they're the person who's been waiting the longest, so they get served next, right? So it's a fairly straightforward data structure. You enter at the end of the line, and then you go to our process at the beginning. So a way to view it is, if we're looking at our linked list again, that this is this is something where we are going to remove someone from the. We're going to add on to the end of the list, and we're going to remove from the front. So always constant time operations there. So your system uses queues. Operating systems use queues to keep track of some kind of resource that you can't always access, like a printer, and then to ensure that tasks are carried out in the order that they are generated. So one common thing you may see, especially in libraries, is a print queue. So printing, because that's slower than actually saying I want to print that, a queue is used saying that we need to print this 52-page document first, then this 46-page document, then this 54-page document. So these are first in, first out. Stacks, on the other hand, are last in, first out, and a print stack is kind of not what we need in this case, because it would mean the most recently submitted thing would basically be the next thing. That means that if you're waiting to print something, I could come in, hit a print, hit the print command, and then my document would go before yours, and somebody could pre-up me, and then we get into this whole game theory here, where if somebody realizes, wait a sec, I could just execute my job again to skip to the head of the line, which would make me realize I could do that to skip ahead of you, and so on and so forth, and nobody's going to print. So we need to make sure. So a stack is thoroughly unuseful for this. We need a queue, so that basically because that's the fairest way. The person who's been waiting longest gets to be the person who's next. All right. Let's see. Did we talk about priority? I believe we talk about priority queues in this. So queues are pretty straightforward. We'll use a queue later on in the semester, but right now you're programming something that deals with depth first search, which says that I'm going to go as deep into a corridor as I can. I'm going to search down a corridor until I hit a dead end. And that uses a stack. Breadth first search will use a queue, and that says I'm going to visit I'm going to go one step down each of these corridors, then 2 steps down each of these corridors, then 3 steps down each of these corridors, then 4 steps down each of these corridors. And that basically ensures that you do this expanding ring of a search. So in this graph over here, depth first search might go something like this: 1 0 3 2 9 8 1 7 6 4 5, and then it backs up all the way to 0. Whereas a breadth first search, and this is more related to chapter 10 material, where breadth first search would start at 0, then it would go 3 and 1, and then would do 2, 4, 7, all the things that were 2 steps away, and then it would do all the things that were 3 steps away. So that's more relevant to chapter 10 though. But queues are used for breadth first traversals. So just like the stack, we have a very simple number of methods. They have 5 here, which I think is like one too many, because we've got this honestly, in my opinion, they don't need these. They don't need to have a pull and remove, and they don't need a peek and element. The difference is whether it returns null or no such element exception. But anyway, I'm going to go ahead and ignore this and ignore this. Offer. That is inserting an item into the rearver queue. It returns true if it's successful, false if you cannot insert it for some reason. Pull, which pulls the front of the queue and returns it. And peek, which looks at the first item in the queue, the front of the queue. Okay, so we're going to go ahead and implement our queue before we continue on. So there we go. So next video, I'll go ahead and implement that using a linked list.